All right, this is lesson 6.6, and we are going to be talking about function operations. Now, we have talked about function form, where instead of writing y, we write f of x or g of x. And so we're basically going to be working with what we've done before, but we're using some different terminology. So for addition, like when you want to add two functions, f of x, g of x, it might be written as f plus g of x. And this just means you're taking the f function and the g function and adding them together. F of x minus g of x can be written as f minus g of x. F of x times g of x can be written like this, f times g of x. The division, you can see, instead of f of x over g of x, could be written as f over g of x. And then this is function composition, which is g of f of x or g of f of x. And what that's saying is you're looking for the value of the g function at the value of what the f function is at x. So first you have to find the value of the f function with whatever value x has, find that answer, and then you're going to substitute that into the g function, and we'll talk about that on the next few slides here. So first of all, f of x equals 4x plus 7, g of x equals the square root of x plus x. What are f plus g and f minus g, and what are their domains? So first of all, f plus g, remember that's referring to f of x and g of x. So all we need to do is substitute in, what does f of x equal? Well, it equals 4x plus 7. Plus, what does g of x equal? It equals the square root of x plus x. And then simplify. So we have 4x and x, which is 5x, combined like terms. And then you have the square root of x and 7. So this is what f of x plus g of x is equal to. And then it says, what are the domains? In other words, what are the values you could substitute in for x? When it asks this, it is assuming that we want our outputs to be in the real numbers. So if we were to substitute in a negative number underneath the square root, you would not have a real solution. So we want a domain that will give us a real solution. So we would say that x has to be greater than or equal to 0. We have a restriction here. You can only put in 0 or positive numbers in for the x here. F minus g means f of x minus g of x. So f of x is 4x plus 7 minus g of x. Now here we do have to be a little bit careful, because whatever g of x is, we want to subtract the whole thing. So I'm going to put parentheses around that. Let's see, let me go back here. Square root of x plus x. And since we're subtracting the whole thing, you want to distribute the negative through. So minus the square root of x minus x. So that gives us 4x minus x, which is 3x, minus the square root of x plus 7. And then lastly, the domain, which was left over from before, would be x is greater than or equal to 0, only because we don't want any negative numbers underneath the root. If there wasn't a square root, we could put all real numbers. Next we have f times g, which means f of x times g of x. So f of x is x squared minus 9. And we want to take that times g of x, which is x plus 3. And I use parentheses because we have to take the whole expression times this whole expression. And so we're going to use FOIL for that, or double distribute. So x squared times x is x cubed. X squared times 3 is 3x squared minus 9x minus 27. And there are no like terms to combine there, so that is our answer. The domain, if we were making an x, y chart, what could we put in for x? We could put anything in for x. So we would say it's all real numbers. Or you could write real numbers, but this is the symbol that you can also use for real numbers. And then f over g means f of x divided by g of x. So f of x is x squared minus 9. G of x is x plus 3. And we always want to simplify. Now, x squared minus 9 could be factored. So we'll do that. That would be x plus 3, x minus 3. That is the difference of two squares right there. So I'm just going to cross that out. This is the factored form. Now, you have an expression in the denominator, x plus 3. It's the same as this expression right here, which is a factor. And when we are dividing, we can cancel factors. X plus 3 in the numerator, x plus 3 in the denominator will cancel. We're left with x minus 3 over 1. So this is our simplified answer. Then, when we talk about the domain, we have to look at the denominator. Now, here's the thing. We can never have 0 in the denominator. So even though in our final answer, the denominator is 1, throughout the problem, if at any point you have 0 in the denominator, the problem's over. So we go back to where we have an x in the denominator. And if you set that equal to 0, we would get x equals a negative 3. So if x equals a negative 3, if you plug negative 3 in right here, negative 3 plus 3 equals 0, you would have 0 in the denominator. So your domain has a restriction. X cannot equal a negative 3. You could put in anything else for x except for negative 3. So that's how we figure out the domain when we have a variable in the denominator. All right, here's another one. Let's actually just do the f divided by g, f of x divided by g of x on this one. So f of x is 3x squared minus 11x minus 4. G of x is 3x plus 1. Now you always want to simplify as much as you can. See if you can factor. Let's see. 4 times 1 gives us 4. And if you look at the outer, that's 12. The inner is 1. So if this is a minus 12 plus 1, that would give you your negative 11 in the denominator. Excuse me. Let me grab a cough drop here. So that's the factored form. And you'll notice you have a factor of 3x plus 1 and 3x plus 1 in the numerator and in the denominator. So those will cancel. Your final answer is x minus 4. And as far as the domain, we don't want to ever have a 0 in the denominator, so we're going to set 3x plus 1 equal to 0 to see what value of x would make it 0. So when x equals negative 1/3, you would end up with a 0 in the denominator. So for your domain, x cannot equal a negative 1/3. Just real quick here, it also asked about what is f times g. So that would be 3x plus 1 times 3x squared minus 11x minus 4. And I will go back and do that one for you. It's been a while since we've done that. Again, this is double distribute. So we're going to multiply 3x times everything. So that would be 9x cubed minus 33x squared minus 12x. And then we have to distribute the 1 through to everything. So plus 3x squared minus 11x minus 4. That gives us 9x cubed minus 30x squared minus 23x minus 4. So this would be the answer, and the domain would be all real numbers, because we could substitute any value in for x. Next, we're going to talk about finding a function's value at certain inputs. So this is saying the function, the f function's value when x is 3. So this is the f function. And so what we're saying, it says f of x is equal to 2x. So f of 3, the output of the f function when x is 3, it means you just take whatever this number is, and instead of x, you put 3. So it would be 2 times 3, and it would be 6. So f of 3, the function's value when x is 3, is equal to 6. This is saying what's the g function's value when x is a negative 4. So the g function is over here. So it would be 5, and the x input is a negative 4 plus 2. And that would be negative 20 plus 2 is a negative 18. So the g function's value when x is a negative 4 equals negative 18. Here's another one, find f of 5. So the f function's value when x is 5. So instead of the x, we're going to put a 5, and that would be 10. Here, we want to know what is the g function's value when x is 7. So 5 times 7 plus 2. So in the g function, we're going to substitute in a 7. So that's 35 plus 2, which is 37. All right, these next examples are function composition. This is saying f of g of 5, which is saying find the f function's value when the input is what the g function's value is when x is 5. So what you first have to do is find the value of the g function when x is 5. So g of 5, so in the g function, which is 5x plus 2, would be 27. And so g of 5 is 27. Now we're going to find the value of the f function when x is 27. So in the f function, we're going to plug in a 27. So it will be 2 times 27, which is 54. Let's do another one. This is g of f of x. Well, we don't have a number, so what does f of x equal? It equals 2x. And now we want to find the g function's value when x is a 2x. So in the g function, we write 5, and instead of x, we put in a 2x. So instead of x, which is right here, we're going to put in a 2x. And then just simplify that. That's 10x plus 2. Function composition. So like I said, g of f of x. First, we have to evaluate f of x first. Whatever that equals, we put that in the input of the g function. Another way of writing it is with an open circle. And I'm not as familiar with that, so whenever I see the open circle, I switch it to this form. So first, find f of x, take that answer, put it in for g. So here we have f of x and g of x. What is g of f of minus 3? Start in the insidemost parentheses. So f of negative 3 would be f of x is x minus 5, so f of negative 3 would be minus 3 minus 5, which is a negative 8. So now that is equal to a negative 8, so we're going to put that value into the g function. So g of negative 8 would be x squared. So instead of the x, we're going to put in a negative 8 and put your parentheses around it, because whatever x is completely has to get squared. That would make a positive 64 for my final answer. What is f of g of x? All right, so g of x, what does that equal? It equals x squared. So now we need to find f of x squared. And so in the f function, instead of x, we're going to put in an x squared. So that would be x squared minus 5. All right, let's do, we'll move down and skip that top one, go to 27. G of x is 2x, h of x is x squared plus 4. So first we're going to find h of g of 1. First of all, find g of 1. So in the g function, substitute in a 1 for the x. And you get 2. So g of 1 is equal to 2. So now in the h function, we're going to substitute in a 2. So it would be 2 squared plus 4, which is 4 plus 4, you get 8. All right, lastly, h of a. So start on the inside, h of a, so in the h function, instead of the x, we're going to put an a. So instead of the x, we're going to put an a. So it would be a squared plus 4. So that's what h of a equals. It equals a squared plus 4. So now in the h function, we're going to substitute in a squared plus 4 instead of the x. So h of x, which now we're going to do h of a squared plus 4, would be, instead of the x, we're going to put in a squared plus 4, and then you have a plus 4. So instead of this x, we're putting in a squared plus 4. Now we need to simplify that. And I forgot to put squared right here, because the x is a squared plus 4, and that gets squared. So that means a squared plus 4 times a squared plus 4 plus 4. So we'll FOIL this out. That's a to the 4th. 4a squared and 4a squared would be 8a squared, plus 4 times 4 is 16, plus 4. Lastly, combine like terms. And there's your final answer. Okay, one last problem. It says find negative 2 times g of x plus f of x. So we're going to be substituting in what the value of g of x is. So it's negative 2 times, what is g of x? X squared minus 3x plus 2. Guys, note that you're taking negative 2 times all of g of x, so when we write it down, we want to put parentheses there. And then we have plus f of x. So instead of f of x, we write 2x plus 5, because that's what f of x equals. So to simplify, first we have to distribute. So we have negative 2x squared plus 6x minus 4 plus 2x minus 5. And then combine like terms. So 6x plus 2x is 8x minus 9. And that is your final answer. And here is the assignment from page 401 that goes along with this lesson. So please get this done. Thanks.